Okay, so as a reminder here, what we're doing is we're going to finish up today on Unit 6. Use substitution is the only topic we have left. It looks horrible at first, admittedly. Once you get the idea, it's no different than what we have been doing. And then during my normal open office hours, whatever, is I'm going to hold another session this afternoon, essentially, going over the test outline. And so obviously totally optional. I will record it. A couple people asked me to do that, so I'll record that and post that as well. And then tomorrow, during our class time at 11 o'clock, I'll open up the test to start. And then you guys, I believe, I want to say it's 120 minutes. I don't know. You can start it whenever you want. It just needs to be done by 3 o'clock. What time is the meeting for the test outline? So I was kind of assuming right after class, but I also get that, yes, you need to be on Zoom for the test. I also kind of get that the students who are in class right now need to go home, and they probably want to watch part of it too. So I'll probably maybe I'll do like a 5-10 minute break in between class and the start of the outline. We'll be going over it for a while, and I'll definitely have time for you guys just to ask questions too. So, if you're not able to make the first part of the outline and you have questions on it, you're welcome to ask them whenever, I have no meetings this afternoon, so I don't mind going longer than 2:15 if there's people on and want to ask questions. So I don't mind. Essentially, I don't mind helping you out get ready. Let's see, what else? I don't know. Do you guys have any other kind of questions before we get started? I'm trying to think if there's anything else I should have needed to talk about or what. I sent a message to everybody. It's actually super difficult for me to cross-check if everybody's signed up for AP Classroom. But we're going to be using AP Classroom in Trimester 3. So if you haven't signed up for AP Classroom yet, you absolutely should have. Originally at the beginning of the year, we were going to intend on using AP Classroom, and then we're just, we found out there's not even remotely enough time with our schedule. Everybody probably should have signed up at the beginning of the year. And this is, so Mr. Stouffer and I just have one class combined. So that way it didn't matter who you had first trimester, and it doesn't matter who you have which trimester. But the important part about the AP Classroom is that's actually how you sign up for the AP test. So signing up in AP Classroom, I can't see the steps you guys take, but I believe one of the steps in signing up for AP Classroom is how you said or determined whether you were going to take the AP test or not. How many more units do we have? We go through Unit 8, so we have 2 more units, and then with whatever time we have left, we're just going to try to get ready for the AP test. At least they have multiple testing dates now, so if you have 3.2 trimester, you'll still get the full trimester in before you take the test, so that is good. Originally 3.2 students were going to be really chopped out of everything, because the first test is like the 3rd day of trimester 3.2. Okay, well then let's get started here. Absolutely, if you guys have any questions you think of during the hour, ask away. It's fine. That's a great question, Natalie. I actually don't know because I can't access most of all that information about you. I want to say our AP coordinator kind of does that automatically. So I believe if you have 3.1 Calc, they'll sign you up for the first test. And if you have 3.2 Calc, I think they sign you up for the third test. The second test date is like in between the two, so it doesn't help anybody, really. I'm not actually sure. If you guys log into AP Classroom, does it give you a choice in there? Because it doesn't let me do like a student view. I have a different version of AP Classroom. Oh, okay. Oh, it says May 4th? Then I'm assuming that's our AP coordinator is the one that has to do all that. Because she's the one that actually sets up all the tests. Her name is, here, I'll write it down. Her name is Beth Salmon. Her email is esalmon1 at SOASHCO. So she's the AP coordinator for our school. The third test is when school is out, correct. So if you do have questions on like the test stuff that I actually have no control over, you can email her and she absolutely can help you out. She's pretty good about it. Okay, so U substitution. This is the final topic here for regular substitution. On the left-hand side, you probably see that box in yellow. I tried to put that right next to most of the questions we're going to work on today. And the reason I have that there is because there's only 5 ways we know how to integrate currently. And what that means is every question you're given will somehow have to fit that 5 methods, right? So this purple one down here, this is the question you would be given, okay? The integral of 2x squared plus 3x cubed times 4x plus 3dx, what would that be? And admittedly, that looks pretty rough. That looks nothing like what we've been doing. And if I would have just given you this question, I kind of guarantee that a lot of people would have cubed this, like FOILed this out 3 times, and then multiplied by 4x plus 3, and then just did the power rule on every individual term. And you can. That would be correct. It would take you forever, but it would be correct, and I wouldn't recommend it. So, but you could. Now, what you're supposed to be able to recognize is you guys are supposed to be good enough at derivatives by now that you should be able to look at this and recognize that 4x plus 3 is the derivative of 2x squared plus 3x. And so what U substitution is we would say let U equal 2x squared plus 3x, and then the derivative of U would be this. So the reason we do this substitution is to take something that looks complicated and turn it into something that is not. So if I put a U in place of 2x squared plus 3x, and the derivative of U is 4x plus 3 times dx, then that tells me the integral would be U to the 4th over 4 plus C. So our final answer would be that, because that was what U is. Correct. Just in case X stands for something else, like maybe x would represent another equation. So it's basically the chain rule is what it is. Because if you do the chain rule on 2x squared plus 3x, this is what it would be in purple. Why do we need du then? It is a very fair question. If we take the derivative of u to the fifth, the answer would be 5u to the fourth times the derivative of whatever u represents. So when you do derivatives, we do that direction for chain rule. If we are integrating, integration goes that direction. So if we are integrating the derivative, the du is important because we would have to have the perfect derivative to go back to what we started with. Yeah, no, that's fine, Kelly. Honestly, I'm going to guess quite a few more people had the same question because that's usually the most confusing part about substitution integration. The du is actually pretty key because it needs to be there to go back to what we started from. So this is kind of the general idea of what we're doing today. Is we're going to try to look for, like this cubed. This cubed was the main thing in this problem that I focused on because I knew that it was a power to be integrated with power rule. I basically saw a parentheses cubed. Are you asking where the 4x plus 3 went? Yeah. So I'll go back to this example here. Maybe. There we go. So when you take derivatives, like if I go the purple direction, when you take derivatives, it's kind of like this. It's kind of like this magically appears out of nowhere, you know, because it wasn't there to begin with. So when you do derivatives, this derivative du appears. But if we're going the opposite direction, if we are integrating, the du has to be there to be able to integrate, but then the answer wouldn't have one. So the answer to that du is, it's a complicated one, but the easiest way I can say it is that when you're doing derivatives, du just appears. When you're doing integration, du has to be there, and then it just goes away for the answer. So it's backwards. Because the whole point of integration is to be able to figure out what equation this is the derivative of. So like du appears in the derivative, but what it came from, it wouldn't have a du. And that's definitely the weird part of integration. Okay, so here's a second example. And obviously you guys don't need to write down these every time. I just wanted them up there as like a reference for you. Okay, so I've got the integral of negative 9x squared plus x plus 4, the whole thing to the 8th power, times negative 18x plus 1 dx. All right, so I'm starting off by trying to write some of these so that the parts of the problem are more obvious. Because once the problems are written differently, sometimes it doesn't feel like the same problem. So I'm starting off by writing them very straightforward. I don't know. I suppose I should call on people. Kayla? Kayla, anything that stands out to you in terms of which one of these 5 we're going to be using on the left, or maybe it might be easier for you to identify is something up there the derivative of something else? I'm not sure what the best question to ask you would be. Okay, good. Very good. So if you're able to identify a derivative within there, that's huge in terms of helping you guys figure out which one of these 5 to use. Now, you know, we admittedly can just eliminate some of them right away. It's clearly not cosine or sine, because that's not written anywhere. It's clearly not e to the x, because there's no e. So it could be one of these 2, and I say could be 1 over x, yeah, who knows, you know, just somewhere from. But since Kayla was able to figure out that this, which I include dx with it, this was the derivative of this, then that's an important start. Because if we are able to figure out, let u equal negative 9x squared plus x plus 4, this is what you have to do on the AP test. If you're going to do u substitution, somewhere on the page you have to say let u equal. And then du would be negative 18x plus 1 dx. Okay, so once I do u substitution, then I'm going to write this as u to the 8th du. And then I'm pretty positive if you write it like that, you know, virtually everybody could figure out what we're supposed to do, because I've got a variable to a power. So in my opinion, what Kayla did first is the most important thing. Is if you can recognize that something is the derivative of something else, that's really key for u substitution. Now, some people can't recognize this right away. And so that's why on the side, I kind of have these 5 listed, because these are the only 5 ways we know how to integrate. And so if you can figure out which one of these 5 it fits, then that could help you figure out what u would be equal to. Like if you recognize that we had a parentheses to the 8th power, well then that kind of tells me it's probably got to be that. So that could help you figure out u. So u to the 8th, if we integrate it, would be u to the 9th divided by 9 plus c. And it's going to be very easy for you to write this as the final answer and forget that u wasn't actually part of the problem to start with. So you would have to resubstitute back, and then you would say negative 9x squared plus x plus 4 to the 9th over 9 plus c. Now, nobody has asked it yet, and I will just answer it. After doing these for a while, I guarantee that some of you will have an easier time doing it mentally. Like in your head, you can picture this as u and this is du. So in your head, you would just do something to the 8th and integrate something to the 8th and turn it into something to the 9th divided by 9 plus c. So I do want to let you guys know that that is fully allowed on the AP test. You don't have to do u substitution on the AP test. If you know how to just like do it in your head, you can. But I don't care however you guys want to do it. Okay, I don't know. Do you guys have questions? I'm going to guess you probably do. It was there. So like look at number 2. I have the integral of 1 over x dx. Dx is the same thing as, so I mean it was there, it's just much smaller. Yeah, and if you guys look on your formula sheets that maybe you would have printed out or something, the formula sheets usually write these formulas with a u instead of an x, and they do that on purpose because they're set up for u substitution. Anybody else? I don't know how this feels so far to you. Derivatives? Chain rule? Yep. Yeah, you absolutely could think of it that way if you want. But yes, correct. It's usually harder to explain that way, so I wouldn't. But yeah, go ahead. Yeah, yeah. I hate to keep referring to this same thing. So when we do derivatives with chain rule, like introduce this extra part that wasn't there before, du. And so no matter how you do derivatives, like which method of derivatives, the chain rule like just creates this extra part out of thin air. And the whole idea with integration is that you're trying to figure out what this came from. So when you're integrating, you have to have this extra little part there to be able to integrate, to go back to what you came from, which won't have that extra little part. Goes away. Yes. Yeah, there's really, for right now, there's probably no other way I can try to explain it other than to just say it disappears. You need to have it to be able to integrate, but it disappears once you do. Okay, let's do another example. So I've got the integral of negative sine of negative x plus 2 dx. So this one's definitely not as obvious. Now, what should be obvious is which one of these 5 we need to use. Okay? And because I've got a sine here, it should be obvious that the sine one is what we're going to use. And the reason that helps us is because we know what parts are supposed to be there, essentially. So my generic formula is that the integral of sine of something should be negative cosine of the angle plus c. But this angle part is what's different than the generic one. So this angle part would have to be our u substitution if it would. We could bring it out front if we wanted to, but we're not going to end up doing that. But otherwise, yes. So normally a multiplier like a 4 or a 5, we would bring out front and not treat it as part of the integration. I'm not doing anything with it yet because I'm trying to figure out the u substitution first. So if u is negative x plus 2, because I don't know if it is or not, I'm basically just trying it. Like this is what you guys are going to end up doing. You guys are just going to like try some. So let u equals negative x plus 2. If that is true, then what would be the derivative of negative x plus 2? So the derivative of negative x would be negative 1. And then derivative of 2 is nothing. So my derivative should be negative 1 dx. And that negative sign in the front is part of du. So negative dx. So if I want to rewrite this, this could be rewritten as sine of u du, because negative dx is kind of like together. So the integral of sine would be negative cosine of u plus c. And then I had already determined that u was that whole parentheses. How are we feeling about this topic so far? Like I know you guys have been asking questions, which is good. Should I ask for like 0 to 5 to start with? Because I don't want to throw you really difficult ones until I kind of know where we're about at. Well, the 0.001 is a little concerning, but I get it, okay. All right. And this is, substitution is not something you traditionally get in a day. So if we were on our normal at school schedule from year to year, 6-period day, we do this like a week. Because calc just needs time to soak in sometimes, like time to soak into your brain. But on our 3-period super rush schedule, we get today. So I'm trying to take it easy on you guys and just go as straightforward as I can. And I don't want you super concerned on the test about this, because I guarantee some of you are. You know, I just know that's how it goes. On the test, the first question you're going to get is I'm going to ask you what should be the u for u substitution. So like I'm just going to give you a problem like this, you know, something similar to this. And then all I'm going to do is I'm going to ask you what u should be for u substitution. You don't even have to do the problem, you just have to identify what you would substitute. So that's why I'm trying to take my time to talk about u substitution quite a bit too. And then you're going to have one pretty straightforward, I don't think it was, Milan, I think it was like fill in the blank. Correct. Nope, Caduce. So like kind of what Lily just said, for this question, you would answer negative x plus 2. Unless that's what you meant. So if I were to ask you what would be the u for u substitution, for this problem you would say negative x plus 2. The sign doesn't count as anything because sign is kind of like an operation. Sign is essentially like a plus sign. It's telling you what to do. You use the sign to get the final answer, so it's not like, yeah, I don't know a better way to say that, I guess. How many questions are on the test? I don't know. I don't have the outline open in front of me. I do actually, hold on. I do have it set up to go over in an hour. 21, but there's a good chance that 21 will be optional. Like, I might make 21 0 points. I can't make it extra credit because that wouldn't be fair to the kids who took it last hex semester. But I might make 21 like 0 points. So, out of these 20 questions, today you're just going to have, I mean, like 2 of them, right? So today isn't a big part of the test at all. That's why I don't want you guys stressing. Do we get to, yeah, you get to use your notes on the test. Wait. You mean for the test? Yeah, I was thinking of a different test. So there aren't any FRQs, but what I'm just going to have you guys do, like the most number of points a question is going to be is 2 points. There are 1 and 2 point questions on the test. Actually, they might all be 2 points. So what I will have you guys do is just to write down your work and turn it in separately. I put an assignment in tomorrow's folder already. That's to turn your work in from the test. And I'll just use that for partial credit. FRQs. I think the third choice of what you were saying. So if you look in tomorrow's folder, there should be a test, and then there should be an assignment that says submit your work for the test here. Because way too many people had problems submitting the work in the test, and that's just, I don't want to do that. Yeah. So that way it should work a lot easier. It's 42 points in the grade book. So if I make question 21 0 points, each question is going to be like 2.1 points. Yeah, 2.1 points. Did I miss any questions? For sine and cosine problems, will the u always be whatever's in the parentheses? Kind of, Ellie. Kind of. I want to show you a question where it's not. Oh yeah, so for Alyssa, yes, you get to use your notes on the test, just like all the rest of the tests. What do you mean that 21 is 0 points? I don't think we're going to have enough time for today for me to feel comfortable giving you a question on definite integrals with u substitution. So question 20, that's what question 21 is. You guys have 4 less class days this hex semester than 2.1 did. So 2.1, I got to stretch out the unit a little bit more. And so I'm not going to punish you guys because you have less time. Don't care. Yeah, I mean, I'll grade it. It'll just be worth 0 points. It won't affect your grade. Yeah. So if you want to answer it, you can. It's not going to affect your grade. If it would be easier, if you guys, I can just delete the question too if that's going to screw you guys up. It really doesn't matter to me. Yeah, that's why I figured I'd leave it for 0 points. And we're going to practice them more. Like it's not like we're going to ignore that part because it's part of the next 2 units. So you guys will definitely get to do it. There's just little details of it that we don't have time to talk about today. Okay, so I suppose we should keep going because we only got oh wait, we're at 1:35. No, we got time. Okay, let's do this question. This one is on the AP test every single year, and so I wanted to make sure to include it. So the integral of ln of x to the 8th over x dx. This one is hard to decipher whether it's supposed to be question 1 or question 2. I mean, it's obvious which ones it's not, right? It's definitely not these three. But it has characteristics that look like 1 and 2. Like, I see a power, okay, so that kind of fits 1. I also see an over something, so that kind of fits 2. So then, here's the logic you guys have to use. If we decide it's question 2, or equation 2, if we decide it's this one, what should be the u substitution if we decide it's number 2? I'll just let anybody answer today rather than just calling on people. It might be easier. Yeah, no, that's what Ola just said too. So if we decide it's equation 2, then the bottom would be the u substitution. So let's try that. So let's let x be u. Wait, I said that backwards. Let u equal x. Well, if u is equal to x, then du would be 1. And that doesn't work for us because we still have stuff on the top. Like if I put a u in place of x, and I put du in place of dx, that doesn't work because there's still x's. So I wanted to show you that one first, because that's the kind of logic you guys have to use. Like you're going to have to try to figure out which one it fits. So it didn't fit number 2. So then that would mean I'm going to try to make it fit number 1. Number 1, that should be the u substitution. Wouldn't you go? Yes, Milan, that's what it's going to end up being. So if I try number 1, the thing that has the power should be my u substitution. And then du would be 1 over x dx. And then that should be where the light bulbs click. Because this would be u. This is 1 over x. Because being over x is like 1 over x. So the u substitution actually makes this u to the 8th times du. Even though the problem didn't look like it at all. But I wanted to go over with you guys how to try to figure out what the u substitution would be. Basically, that wherever the x is on these generic equations, that's the u for u substitution. And it doesn't always fit it, depending on what you have. So then the answer should be u to the 9th over 9 plus c. And for this problem, that would be ln of x to the 9th over 9 plus c. Okay, ask away if something there seems confusing too. I can. The easiest way I can say it, Natalie, if you integrate this, then the answer is ln of absolute value of x. And the whole reason we have absolute value here is because the problem didn't have a natural log to start with. And so the original problem could have negatives in place of x. So they put this absolute value symbol there just because there's like no domain restrictions. The problem we just did actually had an ln of x to start with, so we would have been guaranteed that we could have only used positive x's to start with. So we didn't need to put an absolute value because it would have already been positive x's. Yes. Yep. Where did the x in the x in the denominator? Right. There we go. I basically rewrote the problem, Mary. And instead of writing over x, I wrote it like this in my head. And then this was u, and this was du. So the du goes away when you integrate, and so the x went away. No problem. Well, yeah, I don't have that many questions set up for today because I figured I would have to answer a lot of things. It gives me time to read my email. Super long message from the superintendent. Nope, don't want to read that. Mm-hmm. And this is going to bring us into our next type of u substitution. Why am I getting so many emails? Does anybody have any thoughts on this one? Like, even if you guys, like, which one of the 5 on the left do we think it's going to match up to? Or what should be u? Or what the problem is? Because there's a problem, obviously. Or I should say an issue, because obviously it's a problem. We do problems every day. U-King. What do you think? You hardly ever get called on because you're on the very bottom of the list. Oh, Caduce wrote, it kind of matches with the second one. Okay. How about this? Why did Caduce think it kind of matches with this one? Because I agree with him. It does kind of match that one. Why does it kind of match that one? Oh, you went back on mute? What? Oh no, I still. Oh no, I was definitely asking you. I was just giving you what he said, just if you wanted some help. Why does he think that it kind of matches this? What's different about this one than the other four? It's a fraction. It's a fraction. So the main thing that's different about this second one than the other four is this one is a fraction. You said it's in the denominator, which is correct. Same thing. Okay. So if we use number 2, that's all right, Yu-King, you're still up. I know, you got a horrible question. You're doing great. If it's number 2, I just circled it. What should the u be for the u substitution? So wherever there's an x, so in this case, the bottom of the fraction. Okay. So if it's going to be the second one, then that means the bottom has to be the original, the u, and the top would have to be the derivative, the du. Okay. No, that's okay. You did good. None of this is easy, so that's why I wasn't expecting many people to volunteer. So you did good. Thank you. Yeah, no, kudos. You didn't budge in. I was just asking anybody. So if it's supposed to be the second one, well then the bottom should be the u. So let's just try it. 6x cubed plus 3x. So then du should be 18x squared plus 3 dx. Now, I obviously don't have that up there, but... Oh, okay, good, Mandy. That's good. But I do have a 6x squared plus 1, which actually is awfully close. Because if I were to multiply the top by 3, that would become 18x squared plus 3. And that would become du. But I can't just randomly multiply by 3. So what I can do is I can multiply the outside by 1/3, because multipliers don't matter if they're inside or outside. So if I multiply by 1/3 and 3, it doesn't actually change the problem. But what it does do you can. I'm going to show you a different method, which it's annoying that there's multiple ways to do this. So you can. So this is one method that I'm showing right here. And then what you could do is you could change the problem to be 1/3 integral u, and then this is all du. And so your answer would be 1/3 natural log of u plus c. So that's... Yep. Yeah, the dx is written kind of at the end, but that's the same thing as being on the top of a fraction too. Yeah. So go ahead. It's not the... Well, no, it's... These can be written all sorts of ways, which is what makes it confusing. The reason it has to be the second one is because the bigger power, like the original, is on the bottom, and its derivative is on the top. It definitely could be number 1 if it had a power on the whole thing. Then it could be number 1, And so that's what you're talking about. Yep. Can you put u to the negative 1? Ola, yes. Sort of. So yesterday we talked about why you can't use the power rule on that. And the reason you can't do the power rule on that is because if you add 1, you would be dividing by 0. Because negative 1 plus 1. So the second equation actually is the power rule for negative 1. It seems kind of weird, but that's what happens. I did have the 3 on the numerator. The 1/3 was because I can't just randomly multiply by a 3, because that would change the problem. So I'm technically multiplying by 1/3 and 3, because then that's like multiplying by 1. So it doesn't change the value of the problem. No. So I'll tell you right now, Lily, I can tell that you're going to like the second way much better. So some people understand the top method more, and some people 100% like the bottom method more. And who was that asked this one before? Ellie? I think that was you. Yeah. Wait, who was me? I didn't look. Ellie, yeah. Okay, yep. So the second method is similar, but set up like it's a different setup. You get the same answer. So if you're doing it like this, I believe you had said, why can't you factor out the 3? Oh, that was Mandy. So you can. We don't have 18x squared plus 3 on the top. We have 6x squared plus 1, which you can kind of see is 3 times less. So if you factor out the 3, I'm running out of space. Let me scroll down. If you factor out the 3, what we technically want to do is we want to solve our equation for 6x squared plus 1 dx. Because we already were substituting 6x cubed plus 3x with a u. We want to solve the second equation for 6x squared plus 1 dx. And so to do that, we would divide both sides by 3. So 6x squared plus 1 dx can be replaced with du divided by 3. And then this would turn into 1 over u times du divided by 3. The divided by 3 is a multiplier, so we could bring it out front. And then we could integrate from that screen. Which is the same answer. I believe this second method is how Khan Academy shows it. Every textbook in every place shows it different ways. It's better or for worse, whatever. There's different methods of integrating. I usually like to show both ways. The method that I showed up on top is generally how you do it if you don't like to write out u substitution. The method on the bottom is generally how you do it if you write out u substitution. So people have preferences. Oh, that was the derivative of 6x cubed plus 3x. Like if I do the power rule, 3 times the 6 subtract 1, and then the derivative of 3x is 3. Is that what you're asking? you might have been thinking integration in your head or something and did it the wrong direction or whatever. It's 100% easy to do that once you start doing or integration and derivatives. Okay, so this is essentially what we have to do if we have a du that isn't perfect. Like we can only manipulate things by numbers. If your derivative is off by a variable, you can't do that. But if our derivative is only different by like a multiplier, then we can use these methods to try to figure it out. So here's another one. What are we at? 109? Okay. I do have an example here to show you how to do definite integrals with U substitution. Like I said, it's not going to be worth any points on the test, but I still want to show it to you at least before we separate as a class. So here's our last example that I'll show for today. And I'm going to grade substitution on the test pretty easy. I'm not going to be very harsh on it because you just have it for today. So, like I said, I really don't want you to stress about U substitution on the test. I don't like testing it the day after just as much as you don't like taking a test on it the day after. But it's on the AP test, so it's not like something we can skip and just say, oh well. Okay. Anybody think they have a plan on this one? It doesn't really look like it fits any of those. At least very good. How should we write the square root since none of those 5 have a square root in it? You guys should remember that part. How should we write a square root? Correct. Now, if we wanted to, we could write it like -1/2. Yeah, good. Whoa, weird. My Zoom screen went weird. Yeah, there we go. So we could write it like that if we wanted to. Because it was a denominator, which is true, but it's not going to be this second one because the derivative of this is way more complicated than just an x. So it can't be the second one. But if I write it like this form, it's very possible it could be the power rule because it's a power. Well, that's the -1/2, yep. Yep. So I think what we should try, because I have a parentheses to a power, I think what we should try is to do the power rule. And so that means 16 minus x squared would be u. So then du would be -2x dx. I'll probably try to show it to you the way Khan Academy does because a lot of you might be watching the videos on that later. So I'll try to show it the same way they do it so that you don't feel confused. I have x dx, which is close. So I'm going to divide both sides by -2. And then I have x dx. So now I can substitute x dx. Now I can substitute 16 minus x squared as u. Nope. The only other method that you could do, I'll put it in a different color. The only other method you could do is you can multiply by -2 there and -1/2 out front. That's the only other method possible. Because du has to be perfectly correct to be able to integrate. So we have to do one of those two methods. Now, as you guys do more of these, you're absolutely going to get better at them and not need to show as many steps. So like I'm purposely writing a lot of steps right now because I don't want to lose you in between where I write. Or, I mean, I'll try not to anyway. I'm sure some of you are not in love with u substitution right now. So if I integrate u to the -1/2, I would add 1. Divide by 1/2 is like multiplying by 2 over 1. So negative u to the 1/2 plus c. So my final answer is negative square root 16 minus x squared plus c. And I know this is a lot of information to fit in your brain in one day. I understand. We will be doing u substitution and definite u substitution as part of the next 2 chapters. So this is something you definitely will catch on to. Why is it du over 2? Du over -2. Because what I did was x dx was the only thing I had over there. And so I kept x dx and divided both sides by -2 to make it x dx on it like by itself on the side of the equation. This way I could substitute that exactly in both parts of the equation. Because that's what I had written in the original problem. So I tried changing my info to fit what I had in the original problem. That's for question 19. Question 20 is for you to actually do one of these problems. And that's where I was said I'm going to grade very easy on those. I mean, like, do the best you can. Okay, I'll show you this last one because I don't want to run out of time. And it's not any different. I mean, like, this isn't any more complicated than what we've had. So, ignore the 0 and the pi-4ths to start with. And focus on the integral of sine of 4x dx. First thing we have to figure out is this is going to be u substitution because this isn't a regular angle. So I know this is u substitution. So over on the side, I can tell the angle. The angle is what I need to substitute because it's not just an x. Okay, so if u is 4x, du would be 4 dx. And in the problem, I only have a regular dx, So I'm going to divide by 4 so that I can substitute dx. Because dx and 4x are what I have in the problem. So I need my substitution to fit that. So let's do the substitution. Okay, now I left off a very important part of the problem. A definite integral means that our answer when we're done is a number. So, you know, like doing all this substitution is fine and all, but like we need to figure out the number stuff too. Here's why it's annoying on the AP test. These numbers are x values. Because when we write sine of 4x dx, they're x values. But once you start writing u substitution, you don't have x's anymore. And so we can't write 0 on pi fourths because they're not x values anymore. They're u values. So I have to use my u substitution equation to figure out the u values. So if x is 0, u is 4 times 0, which is 0. If x is pi fourths, u is 4 times pi fourths, or pi. So what I just did was I found my new numbers to put on the integration symbol. These are u values instead of x values. And that's why doing definite integrals with u substitution is annoying, because you kind of have to change it around. The rest of the problem is no different than we've ever done. Like I'm going to integrate sine, which is negative cosine. But I'm not going to write plus c. I'm now going to plug in 0 and pi. And I don't have to switch back to x's because I have u numbers. And I totally, from your standpoint, I'm actually surprised nobody yet has asked, can't you just keep these numbers and then switch it back to x's at the end and then use those numbers? Yes, you could. The College Board has just made it a specific point to tell us that unless you change these numbers, they'll mark it wrong. So that's why I'm teaching you this method. So negative 1/4 cosine from 0 to pi. So negative 1/4 cosine of pi minus negative 1/4 cosine of 0. Cosine of pi is negative 1. Cosine of 0 is positive 1. So I have positive 1/4 plus 1/4, or 1/2. You won't have to. Yesterday I'll be adding points for you guys, so you do not have to do this lesson. You're more than welcome to study however you want for the test tomorrow, but I'm not going to make anybody do, like such a big amount of work. You guys have other classes, and I'm not trying to pretend that you don't. You already have enough homework in Calc as it is. So I wanted to show you this because it's part of our stuff. I'm not going to grade this question on the test, but definitely, practice use substitution tonight. The more you do it, the more comfortable you feel with it, and it doesn't feel so hard. It just takes a little while. And I know we don't have a little while, and I don't like that. But I am telling you that it definitely feels easier after bed. Okay, so we have basically 10 minutes left. I think they're still doing staggered releases, right? I don't know what time you guys get released at, but I'm assuming it possibly be soon. So I'll probably stop here. And then normally I start my open help sessions at 1:35. Should we say 1:45? And that might, I get that not all of you can get home in that amount of time, but then that way if you won't miss much if you do have to drive home possibly. And then I'll just stay on for however long you guys have questions. And then I will record the outline thing separate for anybody else. So, okay. Thank you guys for coming. I will probably see a handful of you again in a tiny bit. I'll start going over the outline at 1:45.